Alright, in this video we're going to be looking at how to graph normal curves to a certain equation of a line or curve or some sort of function. In this example, we need to know the difference between what a tangent is as well as what a normal is. I hope everyone here knows what a tangent is. A tangent is a line that touches the curve at only one point. That is the key. So for example, if I were to sketch a small graph of some random curve, let's suppose like this, a tangent to this curve at this point here would be this line. Okay, it would be this line because it only touches the curve at that one point and it doesn't touch anywhere else. So this line here would be considered tangent. A normal to this curve, however, is simply the perpendicular of your tangent. So the normal to this curve is simply this line here. And as we can see, it does form a right angle with your tangent. And that is what we're going to focus on today. We're going to work out, how do we work out the equation of your tangent lines? Of your normal lines. So the way we do that first is we need to work out the gradient of said tangent line. So the gradient of any tangent line that you have is always worked out by finding the derivative. To work out the derivative of this equation, we simply use the power rule. dy on dx is equal to 2x. And our question here says work out the derivative when x equals 2. So when x equals 2, what is the derivative? It's simply 4. So this is the derivative of our tangent. So if you wanted to work out our tangent, we can simply say that y equals to 4x plus c, where c is some constant, the y-intercept, and this is your gradient. But we don't care about the tangent. Again, the question asks us, what is the normal to this graph? To work out the normal of this graph, we just need to find what is the gradient of the line perpendicular to our tangent. Two lines are perpendicular to each other if their gradients multiply to -1, i.e. they are negative reciprocals of each other. So in this case, if we want to work out the equation of our normal, we want to work out the gradient, all we can do is what number 4 times what gives us -1. In this case, it's just -1/4. And an easy way to think about it is just the negative reciprocal. The negative reciprocal 4 is just -1 on 4, because negative reciprocal. So now we know the equation of our tangent line, the equation of our normal line will be y equals -1/4 x plus c, because we just worked out the gradient of our normal is -1/4. If only we had a point that lies on this curve, if only we had a point that we can substitute into this equation and hence work out what the value of c is. They have given us one, 2, 3. So I'm just going to replace y with 3 and x with 2. So 3 equals -1/4 times 2 plus c. That means 3 equals to -1/2 plus c. That simply means that 3 plus 1/2 is equal to c, and 3 plus 1/2 is simply 7/2. Therefore, the equation of our normal at this point is equal to this. Y equals -1/4 x plus 7/2. That is the equation of your normal of this function. Let's work out the equation for another normal. Let's work out the normal to the graph y equals to 2x plus 1 to the power of 9 at the point 0, 1. And again, we're going to be working out the normal to this function. Pause the video and have it a go. Okay, let's have a go now. To work out the gradient of the normal curve, we first need to work out what is the gradient of our tangent curve. The gradient of our tangent curve can be worked out by simply differentiating. If we were to differentiate this function, we need to use the chain rule. Bring the power to the front, differentiate the inside bracket, and then keep the function, but just -1 from the power. So in this case, it becomes 9 times 2 times 2x plus 1 to the power of 8. And that just simplifies to 18 times 2x plus 1 to the power of 8. Now we want the derivative when x equals 0. So what is dy over dx when x equals 0? Well, that's pretty simple. It's just 18 times 2 times 0 plus 1 to the power of 8. 2 times 0 is 0, plus 1 is 1, to the power of 8 is just 1, so it's just 18. And again, we don't care about this gradient. This gradient gives us the gradient of the tangent. Do I care about the tangent? No, I don't. I care about the normal. To work out the gradient of the normal, all I'm going to do is take the negative reciprocal. The negative reciprocal of this is minus 1 over 18. That is your normal gradient. So we know the equation of our line for the normal curve is y equals negative 1 over 18 x plus c, because we just worked out the gradient. Now we do the same step as before. You want to work out what plus c is? You have a point that the normal passes through, 0, 1. So let's simply substitute that in. 1 equals to 0 plus c, therefore c equals 1. Wow, such a difficult calculation. Therefore, the equation of your normal is simply y equals negative 1 on 18 x plus 1. And that is your normal to this equation. Next question. We're going to be finding the normal to the equation y equals square root 3x plus 1 at the point x equals 0. Pause the video and give this a go. Now, one thing you'll notice with this question is there's only an x value that we got given. Where's the y value? Well, it's not that difficult to work out. We can simply substitute x into this equation and work out what the y value is. So let's first do that. So what is the y value when x equals to 0? It's 3 times 0 plus 1, which is the square root of 1, which is obviously just 1. So we also know when y equals to 1, that's when our normal passes through, the point 0, 1. Okay, let's continue. We need to first differentiate this function, and the way I'm going to differentiate this function to work out the tangent gradient is I'm going to rewrite this function as a power, to power of a half. And if you have done your differentiating practice, you would realize that you would have to use the chain rule. So bring the power to the front, so dy on dx is simply equal to half times by 3 times by 3x plus 1 to the power of negative a half. And if you want to simplify this pretty quick, you can simply just say this is the same as 3 divided by 2 square root 3x plus 1. Now, we're still not done. We still need to work out the gradient of the tangent. So to work out the gradient of your tangent, all we would have to do is just substitute in x equals 0. Substitute x equals 0, and what would we get? We would get 3 divided by 2 times the square root of 1. That just becomes 3 over 2. We don't care about this gradient. This is tangent. That's not what we care about. If we wanted tangent, good job. We don't care about it though. We want the normal. The normal gradient here is minus 2 over 3. You take the reciprocal and then find the negative of it. That is your normal gradient. Let's continue. So you want to work out what is the equation of your normal? Y equals negative 2 on 3 x plus c. What the hell is c? Good question. We have points. Let's substitute it. X equals 0, y equals 1. So then we get 0 plus c. c equals 1 again. Therefore, the equation of your normal for this function is minus 2 over 3 x plus 1. And that's how you work out the normal for this function here. Let's keep it going. The next function we're going to be working out our normal for is tan 2x. Y equals tan 2x, and we want to work it out at the point x equals 0. Again, let's work out the y value because we'll eventually need it for our calculation. If y, well, what is y when x equals 0? So what is the tan of 0? And for those of you that are a little bit confused on how to work this out, you need to know your exact values pretty much. But tan of 0 is simply 0. So that means we know y is equal to 0. Now let's differentiate. We need to differentiate y because we need to work out our derivative of our we need to work out the gradient of our tangent line. The derivative of tan 2x is first 2, and then the derivative of tan is sec x. So it's x squared 2x. Another way you can say this is simply 2 divided by sec squared of 2x. Okay, let's continue on. We need to work out the derivative when x equals 0. So when x equals 0, we can say this is the same as 2 divided by, I meant to say cos here, cos squared of 0, and we know that cos of 0 is 1. So then we can say this is simply equal to 2 divided by 1, which is equal to 2. Continuing on, again, is 2 the gradient we care about here? No, this is our tangent. Pesky tangent, we do not care. What do we actually want? We want the normal. We want the normal to this function, which is the negative reciprocal. Therefore, the negative reciprocal of this function, the gradient of it, will be negative a half. So now what is the equation of our tangent? The equation of our tangent is simply y, sorry, not tangent, normal. Tangents are pesky. Y equals negative a half x plus c. Now that we have the gradient, we need to work out the y-intercept. We need to work out plus c. 0, 0 makes our calculation very, very simple. 0 equals 0 plus c. Wow, 0 equals c. What a crazy calculation. So that means y is simply negative a half x. That is the equation of your normal for this function here. The next one we're going to be doing is this one here. Work out the normal to this function. And we're going to work it out, change it up a bit, at x equals 2. Okay, we need you to work out the normal to this function at x equals 2. Pause the video and give it a go. Alright, first thing we need to do, again, work out y values. What is the y value when x equals 2? So this is the same as 2e to the 2 squared, which is simply 2e to the 4. You could keep this as a decimal. I'm too lazy. We're just going to say y equals 2e to the 4. Let's continue. To work out the derivative, so we would need to use the product rule. We keep this, differentiate this. I forgot to keep it. So x, and then we can do times 2x e to the x squared. Then we can do plus the other way around. Differentiate the x, that's just 1, and then you can keep e to the x squared. Now what do we have? We have 2x squared e to the x squared plus e to the x squared. And if you really, really want to, you can factorize this out, e to the x squared, and you'll be left with 2x squared plus 1. Now, let's work out what is the first derivative when x equals 2. When x equals 2, it's e to the 4 times by 4 squared. So 2 squared is 4 times 2 is 8 plus 1. So that's 9. So this is equal to 9e to the 4. All right, we just worked out the gradient when x equals to 2. So we worked out the gradient when x equals 2. We don't care about this gradient. We care about the negative reciprocal. Because again, this is our pesky tangent. We want our normal. So to work out normal, it's negative 1 divided by 9e to the 4. This is our normal. So now we have this function here. We're going to work out the normal line. Normal line is y equals negative 1 divided by 9e to the 4x plus c. Don't be confused by the amount of letters and numbers around. We just worked out the gradient of our normal line, and then we just chucked the x plus c, because our equation of a line is y equals mx plus c. Continuing on, we need to work out the value of c. Did we work out the y value? Yes, we did, 2e to the 4. So 2e to the 4 is y, and x equals 2. The math does get pretty complicated, but it's fine, it's not that bad. Okay, first thing I'm going to do is rearrange everything for c. So c equals to 2e to the 4 plus 2 over 9e to the 4. Now, if you want, you can just keep it like this. There's nothing wrong with it. This is the value of c. Okay, if this is the value of c, let us work out the equation of our normal. You can say y equals to negative 1 over 9 e to the 4 x plus 2e to the 4 plus 2 over 9e to the 4. That is the equation of the normal to this function. This is the normal. Let's keep it going. We're going to work out the tangent, not the tangent. We literally just said not the tangent. We're going to work out equation of our normal that passes through y equals ln of x. We'll make it easier, harder. ln of a third x passes through the point a, comma, ln a. What is the equation of the tangent that passes through this curve? Pause the video and try it for yourself. I meant the normal, I keep saying tangent. Okay, let's try it. First thing we need to do, we don't need to work out the y value. They've already generously given it to us. Let's differentiate. The derivative of this is f dash x divided by f of x. So what is the derivative of the inside function? It's a third, and then we just keep the inside bracket, a third x. But as you can see, we can simply cancel out the 1/3 and the 1/3. So the derivative for anything ln kx is always 1 over x. Okay, so now we need to work out what is the derivative, the gradient. dy on dx, when x equals 1 over a. Sorry, not 1 over a, when x equals a is equal to 1 over a. But do we care about this? Again, no, this is pesky tangent. Okay, we want normal. The normal will be the negative reciprocal, which is negative a on 1. That's the same as just negative a. This is normal. Okay, that's what we care about. So continuing on, we're going to work out the equation of our normal. Y equals negative ax plus c. Now that we have this, we need to work out the value of c by subbing in this point here. So we can say ln of a is equal to minus a squared, because we can say minus a times a plus c. And then we can say that c is simply equal to a squared plus ln a. That is the value of c. So now if you want to work out the tangent line, I keep saying tangent, the normal line, we want to work out the normal line. Y is equal to minus ax plus a squared plus ln a. This equation here will always give us the value of our normal. And that's how you work out normals.